Hello and welcome back. My name is Constantine, and today we're going to go through a problem, find first and last position of an element in a sorted array. Reading the problem, the first thing that I'm seeing is this time complexity, O log n. So this is one of the biggest clues just because it tells us that we need to have binary search algorithm implementation in order to get to this time complexity. So we have a nums array, right, and which we know is sorted in an increasing order or non-decreasing order, and we have a target. So we want to find out if the target first exists in our array, and if it does, we need to return an integer array with two elements, and the elements being the first position and the last position of our target in the array. So in this case, if our target is 8, we're just going to return index 3 and index 4 positions where our element appears. So how are we going to implement this solution? How can we think about this problem? By the way, if we don't find the element, we'll just return -1 and -1. So that's technically an easy case. But how are we going to find out if the first and the last position of an element? So let's get to our whiteboard and let's assume this is our array right here. And our target, for example, it will be equal to 4 in our case. So we want to find out if 4 exists, and we see a 4 right here, and we want to return two elements. We want to return index 6 and index 7 just because it's the first and the last position of our element. So how are we going to do that? So my initial approach when I solved this problem a while ago, it was just to find out if the element exists, find out if 4 exists, and then from here have a linear scan which goes all the way here and then all the way here. So from here find out if there are any 4 before that or if there's any 4 after that, and just get the first and the last position. And that's a pretty good solution, but it will not pass in most of the cases, just because think about if you would have 1 1 1 1 a million times, right? 1, and then we would find a 1 right here, and then we would want to do a linear search this way and a linear search this way. That will take us to O of n time complexity, right? So they asked us to do a log n, which we know it's a binary search. So how are we going to do that? I think it's very easy for this problem to imagine that you don't have to do this at the same time. So what I mean by that is, why don't we just find out first the first occurrence, the first index, write a method to find out the first index, and then write a method to find out the second index. And then we could just return an array with calling the first method and the second method. So let's see how we would do our first index. So we would start at 0, our start, right? Our end will be 9, and we'll compute our mid, which will be 4 in this case, right? So the first thing we're going to look is this element right here. And we're going to take a look and we're going to compare this element, nums of I, right? We're going to compare it to 4. If it's less than 4, which in this case it is, we know that since this is a sorted array, we can't find the answer in this half, right? So we could just disregard this half. We can move our left pointer to mid plus 1. So our left pointer, then therefore our answers needs to be in this half of the array, right? So we'll move our left to mid plus 1, and we're computing again our mid, and in this case our mid is 7, our new mid, right? So our mid is 7. So right now we're comparing this 4 to 4. So what do we see right now? Is this greater? Usually we would do, is this greater? Yes, it is. So we're moving our right to mid minus 1. So we're moving our right to mid minus 1, which is 6. But then we could also have a Boolean to know if we found this element. Boolean found. And once we found it, because our second condition, if it's greater than equal, then we could just set this to true. So in this case, we found it. We know it's in there. we just need to find the first occurrence. So right now our mid is equal to, our mid was 7 and our right was mid minus 1, so it's 6 right now. So let's compute again our mid, and right now our mid is going to be equal 5. So right now we're looking only in this little portion right here, and this is our mid. It's almost like intervals if you have done those type of problems. So right now this is our mid, so we're comparing 2 and 4 and we see it's less. So we know that we need to increase our mid to mid plus 1, right? So our start is going to be equal to 6, and this is our last basically iteration because we're running this loop as long as our left is less than or equal to right. So right now we're moving our start to index 6, and that corresponds with our first iteration. And we're doing exactly the same thing, but just a little bit twitched reverse to find out the last occurrence of our target if we find it in the array. So in this way, we make sure we achieve a O of log n time complexity. It's exactly what they ask for, and you will pretty much pass all the test cases. So let's go to Leetcode super quick and code it very quickly. So I said that I will have two methods. I will have a private, which will return an int, find first, and it will take a integer my nums and my target. And in here is just basically binary search, right? So I'll have an int left equals 0, int right equal nums length minus 1. Oops, I was not looking here. Oops, I guess I'm touching the drawing tablet. Int left equals 0, int right equal nums length minus 1. And we said we also need a boolean to know if we found it, right? So I'll get a boolean found, which will be equal to false because I didn't find it yet. For some reason I can't type, but that's okay. All right, so now we're gonna go in our loop. So while my left is less than or equal to my right, I'm gonna compute my mid, just basic binary search. Right minus left divided by 2. And then here's my logic. If my nums of mid, right, is greater than or equal to my target, so in this case it means that I found the number. So I could have just an if condition right here. If my nums of mid equal to my target, then I could just set this boolean found to true, just to know if I found it or not. And after that, what I have to do is I will move my right equal to mid minus 1, or else here left is equal to mid plus 1. And in my return statement, I want to know if I found a number. So return if f is equal to true, I will return my left, otherwise I'll return minus 1. So I'll copy exactly the same method. So that's technically, right now we're finding the first occurrence, and then I will have exactly the same method as I said, and right now I want to find the last occurrence. So the only twitch that we need to do right here is if my nums of mid is less than or equal to my target, I will just switch these two statements. So I will just basically inverse them. And with that being said, here we can just simply return a new or we could probably do some basic checks to see, or actually in a real interview I would advise you to ask like if nums could contain 0 elements, or what happens if we have no elements, and so on. But in this case I think we could just return a new integer where we'll call our first method. So our first element, you will be calling find first, and we'll pass our nums and our target. And our second element, you will be, we're calling the last method, find last, and we're passing our nums and our target. So I think that should be it. It will return basically if we found an element or not. So let's give it a try. Left -1. Okay, just because this is found, and the same thing here. Oops, and here I want to return right element, not left. And voila, it seems like it's working, and there's no other way around. It shall work. So that's it for this problem. Thank you so much for watching this video. Please consider subscribing or liking if you consider you've learned anything from this video. And if you have any questions that you would want me to solve, please let me know in the comments. Thank you, and I'll see you in the next video.